This video is about exponents. The first thing that we need to talk about is, again, some vocabulary. So first we're going to start with the big number. This big number is called a base, and the little number above and to the right is called an exponent. The exponent tells us that we are doing repeated multiplication. We are repeatedly multiplying the base the number of times indicated by the exponent. So 3 to the second power, that's how you read this, or 3, and an exponent of 2 has a special meaning, it's squared. So this says 3 squared is equal to 3 times 3, the base used as a factor 2 times. And 3 times 3 is equal to 9. So this is called expanding the exponential notation, and this is what the value is, simplified. Okay, from there, let's go ahead and give you a chance to try a few of these and see if you've got the idea. So you should pause your video and you should see if you can get the answers all by yourself without any help. Now some of these could be challenging, so don't worry about it. I will come and help you with them as soon as I figure you'll have a chance to do them, or until you turn on the video. All right, so our first one here says 5 to the third power. The third power also has a special name. We call this cubed. That's C-U-B-E-D, cubed. So it can be said as 5 to the third power or 5 cubed. This means 5 times 5 times 5. We're using the base 5 as a factor 3 times. So we get the answer by saying 5 times 5, which is 25, and then 25 times 5, which is 125. If you need to multiply that out long multiplication, go ahead. All right, our next one is 1/2 squared. Remember that the second exponent, or the exponent of 2, has a special name that we can use, and that is squared. So 1/2 squared, or it could be said as 1/2 to the second power. That means we're going to use the 1/2 as a base, or the base as a factor 2 times. 1/2 times 1/2, 2 factors of 1/2. And multiplying fractions, remember, is quite easy. We multiply the numerators. 1 times 1 is 1. And we multiply the denominators. 2 times 2 is 4. So 1/2 squared is 1/4, or 1/4. Moving on to the decimal. This says 1, or 0.1, or 1/10 to the 4th power. Now there's no special name for the exponent of 4, we just say to the 4th power. So this means 0.1 times, and I'm going to use parentheses around this to say multiply because the decimals, that makes it kind of confusing if we use some of our other notations. So 0.1 times 0.1 times 0.1 times 0.1. So the first thing that I'm going to do is I'm going to say, okay, 0.1 times 0.1. So we ignore decimals, 1 times 1, which is 1, and then we need to put 1, 2 decimals into it. So 1, 2 decimals into it. So we get 0.01, or 1/100th. And these two, we can do the same thing. That's also going to give us 0.01, or 1/100th. And then we'll multiply 1/100th times 1/100th. Ignore the decimals again, 1 times 1, which is 1, and then we need 1, 2, 3, 4 decimal places. So 1, 2, 3, 4 decimal places, and the decimal goes there. I like to put it at 0 before my decimal, but that's unnecessary. And there's our answer. Now remember, tenths, hundredths, thousandths, 10,000ths, so this is 1/10,000ths. Okay, now the last one here, anything to the first power, is a special. This is actually a special definition, but this just means that we're going to get the number itself back, right? right? Because it's used as a factor one single time. So whether we write the first power or not, it means the same exact thing as just writing the base. And so that's something that's kind of an important thing to know. All right, moving on. Now we're going to use exponential notation to rewrite a product. So the first thing that we want to do is we want to learn how to write 2 times 2 times 2 using what we call exponential notation. That's just a fancy way of saying using exponents. So first of all, I'm going to identify the number that's being repeatedly multiplied. So you see 2 is being repeatedly multiplied. So I'm going to write that down. And then the next thing I'm going to identify is how many times is 2 being repeated, or how many times is 2 used as a factor. It's 1, 2, and 3 times. So I'm going to put the exponent of the 3 up here. So 2 to the third power, or 2 cubed, is how I would represent 2 times 2 times 2. Now, exponential notation is important as an application because it allows us to write things in a little easier manner. So let's use prime factorization of 36 and write the answer as exponential notation, or using exponents. So remember, prime factorization, I'm going to write 36 and I'm going to say, okay, what's the smallest prime number that goes into 36? Or you can use any two numbers that you can think of that go into 36 if you want, but if we start with the smallest one, that would be 2, and that would be times 18. So 2 is prime, so I circle it, and then 18 is not, so I do it again. 2 times 9. 2 is prime, so I circle it, and then I do 9 because it's not, and 9 is 3 times 3. So 3 and 3. All right, now let's use our exponential notation. So remember, we can rewrite this as a product: 2 times 2 times 3 times 3. Now, it's still a really good idea to check that and make sure that you got the right answer before you move on to the exponential notation. So let's try. 2 times 2 is 4. 4 times 3 is 12, and 12 times 3 is 36. So yes, we got the right answer. All right, so now I'm going to look, and I see, oh, well, look at this. I have repeated multiplication of 2's. So 2's are being repeatedly multiplied. How many times are they being repeated? 1, 2 times. So that's going to make an exponent of 2. Now, I also have 3's that are being repeatedly multiplied, right here. So 3's, so it's a base, and how many times is it repeatedly multiplied? 1, 2. So the 3 also has an exponent of 2. And there's my exponential notation for the prime factors of 36. And that's a good place as an application. Next, we're going to talk about radicals, and I think I'm going to leave this for the next video, but radicals are related to exponents because they undo an exponent.